Good afternoon and happy Earth Day. My name is Scott Hosking. I am a Turing Research Fellow for Environmental Data Science, head of the Artificial Intelligence Lab at the British Antarctic Survey, and a co-director of the Centre for Doctoral Training in AI for Environmental Risks at the University of Cambridge. Thank you for joining us today during these very strange times. I hope you are all keeping well. We are currently in the midst of a global health crisis, COVID-19. And the UK, along with the rest of the world, is having to adjust to these unusual ways of working to allow us to continue whilst protecting our health and those around us. For many of us, this means working from home. And so today's Turing Lecture is coming to you live from our homes to yours. The Turing Lectures is the Institute's flagship lecture series, which have been running since 2016. I'm very excited to be hosting our very first virtual Turing Lecture with the brilliant Emily Shuckburgh. Before we get going, a few housekeeping notes. Today's event will be subtitled, so if you're unable to see the subtitles and you would like to, you can submit questions down below in the Zoom Q&A. You could do this throughout the lecture or on Twitter using our hashtags Turing Lecture and Earth Day. We're expecting a lot of questions this afternoon, and we'll not be able to get through as many as you'd like, so apologies in advance and if we do not get around to yours. If you're on Twitter, please discuss and feedback on the lecture. A reminder of those hashtags again, Turing Lecture and Earth Day, and don't forget to tag us at Turing Inst. We will be recording this lecture and it will be hosted on YouTube afterwards, so if you need to log off for any reason, you can catch us later. The benefit of running these events virtually is that we can start playing around with some of the cool tech. So we will be running live polls throughout the event. If you're streaming in via Zoom, look out for questions popping up on your screen. We'd love to know what you think about some of the topics we're going to cover today. As you will have experienced, technical glitches are becoming the everyday norm. So please bear with us if any of those happen. Now, without further ado, let me introduce you to our speaker, Dr. Emily Shuckburgh, OBE, Director of Cambridge Zero, the University of Cambridge's Zero Carbon Future Initiative. Emily is a leading climate scientist and mathematician and a fellow of Darwin College, Cambridge, the Cambridge Institute for Sustainability Leadership, and the British Antarctic Survey, and an associate fellow of the Centre for Science and Policy. She leads the UKRI Centre for Doctoral Training in AI for Environmental Risks and has acted as an advisor to the UK government on behalf of the Natural Environment Research Council, and has even co-authored a Ladybird guidebook on climate change with His Royal Highness the Prince of Wales and environmentalist Tony Juniper. Okay, we don't have a lot of time, so I'm going to hand you straight over to Emily. Thank you.
Okay, thank you very much, Scott, and welcome to everyone online, and welcome to the 50th anniversary of Earth Day. I'm going to be talking to you today about climate change, but I also want to tell you the ways in which we are starting to use AI, both to understand the challenges associated with climate change, but also how we might respond to climate change. So let me start sharing my presentation. The title of the presentation is Plan AI, because there is no planet B. Now, what I'm going to do, if I can, is, or maybe I can't, how do I do this? Sorry, everyone. Oh, there we go. Maybe we'll have to stay with my video. Right, so this first image that I have here looks like a rather uninspiring stone, but it's actually the oldest object in the British Museum in London. It's a stone chopping tool that comes from East Africa and was first made about 1.8 million years ago by very early humans. And the reason that I put it up here, well, it really is twofold. The first is because that ability to create and use tools is, of course, one of the key attributes of what it is to be human. So this really marks the very start of if you like, the evolution of humankind, which you might say is starting, culminating through today in our development of new technologies, such as the ability to use AI. But the other reason that I put it up here is because I really wanted to highlight that the carbon dioxide levels that we are breathing in today are higher than they have been at any time throughout this whole period of human history, and indeed for at least 1 million years earlier than this. And you can ask why we know that. And one of the key pieces of evidence that we have for understanding what those levels of carbon dioxide in the distant past were are ice cores that are drilled from Antarctica. Now, what you're going to have to do, I think, because we've got the videos on the screen as well of me, so what you might want to do, when there's bits underneath the videos that you want to be able to see, you might want to move the video. I think you can do that with your, if you move the videos around, you can see the bits underneath the screen. But what you can see here on the screen is a photograph of a slice through an ice core, showing tiny bubbles of air in that ice core. And as I will show you in a moment, it's those tiny bubbles of air that are ancient air, in this case coming from about, well, almost 1 million years ago, that tell us what the atmosphere was like in the past. Now, what I'm going to show you in a second is a little animation that I produced a couple of years ago with children's author Chris Horton for the Hay Festival in collaboration with the Natural Environment Research Council, which will give you a little bit of a insight into both how we obtain these ice cores and what they actually show us. So let's see. Oh, now.
This is Antarctica. It's cold in Antarctica. It's always cold. In fact, it's been cold for such a long time that a lot of the snow hasn't melted for millions of years. All that time, it just keeps piling up, deeper and deeper. So today, in places across Antarctica, the snow is over 3 kilometers deep. Over time, this snow packs together. It crushes under its own weight so tightly that it becomes solid ice. But it isn't completely solid. It contains tiny bubbles. These bubbles of air have been sealed off from the world since the time they were formed hundreds of thousands of years ago. That makes them very interesting for climate scientists. The scientists at the British Antarctic Survey have taken samples of ice from the surface to the bottom 3 kilometers down. By measuring the CO2 in the air bubbles, they have charted its level back through the years. CO2 is a greenhouse gas. That means it traps heat, acting like a blanket that warms the Earth. The more CO2, the warmer the Earth. It's low during ice ages and high during warm periods. During ice ages, huge sheets of ice, kilometers thick, form across Europe, Asia, and North America. During the warm periods, like today, the ice retreats. Low CO2, high CO2. Low, high. Low, high. So what are the CO2 levels that we are recording today? They are much, much higher. That's because burning fossil fuels releases CO2. And in recent years, we have been releasing more and more CO2 into the atmosphere, from our homes, from factories, and from cars and planes. Forests absorb CO2, but we have been cutting our forests down all around the world. This CO2 will continue warming the planet whilst it remains in the atmosphere. And meanwhile, we are emitting even more. The polar regions are warming and melting. That's very bad news for rising sea levels, and it will also have a devastating effect on wildlife here. There are ways we can reduce our emissions and at the same time improve the quality of our lives. We will all need to act, and act now together. Please help. We need to limit CO2 now.
So this was the graph that we saw in that little animation there. This is the levels of carbon dioxide in the atmosphere over the last 800,000 years that have been obtained from those ice core samples. And as was described in the video, you can see that over this last nearly million years, they varied up and down as we've moved in and out of ice ages between about 180 and 280 parts per million. But if we look at where carbon dioxide levels are today, they are very substantially higher. Now, I just highlighted this one point here just to give you a sense again of quite how far back in time this covers. This picture here is actually from the Sedgwick Museum in Cambridge, and in amongst the dinosaur bones, you can see this picture, which is a reconstruction of what an area just outside Cambridge might have looked like 120,000 years ago, in the last warm period in the Earth's history. And you can see that back then, when carbon dioxide levels were in one of those higher periods, up around 280 parts per million, then we had these giant elephants and hippos that were wandering around the rivers outside of Cambridge. And as we then moved into the most recent ice age, those were replaced by woolly mammoths. So we've seen very, very different climates and very different worlds in this period of the Earth's history. So this, though, is where carbon dioxide levels are today. 410 or more parts per million, vastly outside that natural cycle of change over the last, well, certainly million, but probably further back in time as well. So really, today's atmosphere is unprecedented. Now, let's look at another number, 85 parts per million. Why do I put up the number 85 parts per million? Well, the first Earth Day was back in 1970. This is the 50th anniversary of Earth Day. And 85 parts per million is the amount of increase in carbon dioxide in the atmosphere that we've seen just over those last 50 years. As I described, between those very different periods of Earth's history, with those ice ages with woolly mammoths and the much warmer periods with giant elephants, just in the area outside Cambridge, the difference in carbon dioxide levels was not much more, around about 100 parts per million. So just in the last 50 years, we've almost seen as much change in carbon dioxide levels as between those two very different worlds. What I'm showing you here is now just looking in at the last 150 years, and not just looking at how the climate has changed over the last 150 years, but also how our society has changed. And this, of course, is intimately related. So over the last 150 years, we've seen a transformation in the economies and societies of the world. This is indicated in the top graph here, which shows a 100-fold increase in global GDP. And of course, much of that transformation has occurred as a result of industrialization, primarily using fossil fuels for our energy use, but also transforming our land surface. You can see here a 20-fold increase in global energy use. And both that increase in the use of fossil fuels for energy and transformation of our land surfaces has transformed our atmosphere. And we've seen that in terms of the increase in carbon dioxide levels that I've shown you. Carbon dioxide is a greenhouse gas, so you would expect that an increase in carbon dioxide in the atmosphere would be associated with an increase in the surface temperature of the Earth. And indeed, that's what we see. At the bottom there, you see just over a 1 degree increase in the temperature of the surface of the Earth over this 150 years. And as we've seen that warming, there's also been a lot of other knock-on effects on the rest of the climate system. And the final graph that I'm showing you here is just one example of that. As the atmosphere has been warming up, then slowly other parts of the climate system have also been warming up. And as the water in the oceans warms up, then literally the oceans expand in volume. And so we've been seeing sea level rise as a consequence. But in addition, that warming has resulted in melting of ice around the world. And where that ice is sat on land, it eventually finds its way into the water of the oceans, and similarly causes an increase in sea level. So globally, as is shown here, we've seen around about 1/4 of a metre of sea level rise over the last 150 years. Now, just today, the latest report on climate change, specifically in Europe, was released. And here are some of the headline findings of that. So the last 5 years globally, as I described, have been just over 1 degree warmer than they were in what we call pre-industrial times, that period around about 150 years ago, before the start of the Industrial Revolution really started to ramp up. In general, we've been seeing that land areas have warmed up more than the ocean surface. And so Europe itself has warmed up more than the global average. And we've seen that there's been around about 2 degrees of warming in Europe over the last 100 years or so, since the late 19th century. This last year, 2019, was the warmest year on record for Europe. And indeed, 11 of the 12 warmest years occurred since the turn of the millennium in Europe. Oops. Now, just one very visual example of those changes, which some people might have even visited, is one of the glaciers in the Alps region, just outside, around the corner from Mont Blanc. And this, you see here, a couple of images of that glacier. The first is a postcard from around about 1900 showing the glacier, which is called the Mer de Glace glacier, because as you can see in that postcard, it used to really very much look like a sea of ice. The photograph that you see at the bottom is what that glacier looks like today. It's seen very, very substantial retreat. But perhaps one of the most striking examples of exactly how much retreat we've been seeing is this. You can go as a tourist to go and look at that glacier, and the photograph that you see on the bottom right is of an ice cave that you can go and visit. And a cable car was put in place back in 1988 to help tourists go and visit the glacier. And back in 1988, you could just step straight off the cable car and into the ice cave. But so much has there been melting over the last couple of decades that today you have to walk down nearly 500 steps in order to get to the entrance of the ice cave. Really, there's been very dramatic change to this glacier and to very many glaciers around the world. And I really want to emphasize that it's not just the warming. We're also seeing many other knock-on impacts of climate change. Ice loss from Greenland and Antarctica is accelerating. We've seen twice as much ice loss over the last decade compared to the previous one from Greenland, and 3 times as much from Antarctica. And as I've already described, that's having an impact on sea level rise. In terms of the oceans, oxygen levels in many parts of the ocean are dropping, causing severe impacts to the marine wildlife. And a really critical aspect for the oceans that also is associated with raised levels of carbon dioxide is that as a consequence of those raised levels of carbon dioxide, we're seeing the oceans increasingly become more acidic, and that has a very damaging effect on marine life. Perhaps though, the aspect of climate change that has the most dramatic impact on society is the change in risk of extreme weather events. What you see on this image at the back is a map that's been put together by an organization called Carbon Brief, which collates all the studies that are being conducted over the last few years that look at actual extreme weather events that have occurred around the world and ask the question, has the risk of those extreme weather events increased as a consequence of the climate change we've already seen to date? And all the examples that you see indicated in red are examples of extreme weather events that have occurred in recent years, where it's been able to be demonstrated scientifically that the risk of those extreme weather events has increased, and in many cases increased very significantly as a consequence of the climate change we've already observed to date. And just two examples that I highlight, we saw a very severe heat wave in the UK last summer. One of the pictures that you see at the top there was taken at the Botanic Gardens in Cambridge, which achieved the UK record temperature of 38.7 degrees Celsius, which I can tell you was quite unpleasant because I was in Cambridge on that day. And the other image is of flooding that we saw at the end of last year. This comes from, I believe, Doncaster in the north of England. But we've seen numerous flooding events in recent years in the UK. And you can ask, why is that connected with climate change? And it's connected because a warmer atmosphere is able to hold more water vapor. And so the atmosphere is literally wetter, which gives an increased risk of heavy rainfall events. And that's the primary reason for the connection between the two. Now, extreme weather event can have direct impacts on people's homes and businesses, for example, in the sort of flooding events that I've just described, but they can also have indirect impacts. For example, climate change that might occur elsewhere in the world can affect our global supply chains of food. And so it's not just climate change that happens here in the UK that has the potential to cause implications for us in the UK. And as we are seeing more and more, as I showed in the last image, examples of the impacts of climate change around the world, then it's that collective impact of climate change that is of real concern. But as we're sitting in the midst of another global emergency, the other key consideration here is how all these different risks interconnect. So the impacts of climate change can't be considered in isolation of the risks of other aspects. So let's just take the global pandemic. On the one hand, the fact that we are in the midst of a global pandemic means that if we see an extreme weather event occurring around the world, a tropical cyclone coming in, for example, we might normally be looking to evacuate people to reduce the damage caused by those tropical cyclones. But the evacuation is going to be so much more difficult when we're in the midst of a global pandemic with the lockdowns that we're seeing around the world. Or another example would be, we've seen repeated extreme heat waves occurring around the world. When our health systems are under so much more strain and stress as a consequence of the global pandemic, then it is going to be so much more difficult to respond to the health impacts of heat waves occurring around the world. All these risks are highly interconnected, and understanding and quantifying those interconnected risks is critically important. And that's one way in which we've been starting to try and bring in tools and techniques from AI. I'm not going to go through all the details in this slide, but what we have started to be doing, and actually Scott, who provided the introduction here, has been involved in this work as well. We've started to look to see how we can use tools and techniques from data science, from using AI, machine learning techniques to integrate all the different knowledge that we have around the risks and the impacts of climate change to provide information that can help decision making in terms of both quantifying the risks of climate change, but also understanding how to build resilience to those risks. And that involves being able to quantify risks at a very local level, to understand the risks at a particular location. In this instance, it's looking in at Chicago in the United States and the risk of different extreme weather events under different future scenarios. So climate change poses risks both to humans, but also to the natural world. And I've just got a few examples. First of all, looking at the risks to humans, and again, taking examples from recent times. The very top image that's shown here is of a cyclone that tore through southern Africa. This is showing an island off the coast of Mozambique that was devastated by that cyclone, and it's estimated that as the warming increases, we're currently, as I said, just over 1 degree of warming, as it increases to 1.5, and if it were increased above that towards 2 degrees of warming, then literally several 100 million additional people are likely to be exposed to the risks both of climate change but also of extreme poverty. And it's not just to people elsewhere in the world. We've seen risks to businesses and to communities in the UK as well. And there's just a couple of images of the impacts of climate change on businesses shown there as well. But turning to the natural world, so much of the natural world is already under severe threat. Last year, a report concluded that around 1 million species were at risks of extinction over the coming decades. And climate change exacerbates what are already severe threats to many species. And I wanted just to describe a few examples of that. So if we look at the middle images there, the top image is of a mountain blackbird, a ring ouzel, and it's an example of a species which already lives at high altitudes in cool habitats, and consequently, as the world warms up, it doesn't really have anywhere cooler to be able to go, and it's a risk. It's a British bird species. It's a risk of becoming extinct within the British Isles if climate change continues to increase. And similarly, the penguins that are shown at the bottom there are another species, polar species, already in the coldest part of the world. They don't have anywhere else they could go as the world starts to warm up and are particularly vulnerable to climate change. And it's not just the changes, immediate changes in the conditions. The example that I have on the right-hand side at the top is of a blue tit, and it's an example of a species that's very dependent on the seasonal cycles. They are very dependent, as is shown in this photograph here, of using caterpillars to feed their young. If there starts to be a mismatch in the seasons through changes to the seasons between when the caterpillars emerge and when their eggs are hatching, then they can suffer very severe impacts. And the bottom example is of a very rich part of the marine ecosystem, kelp forests. We're seeing increasing frequency of marine heat waves, which is causing many impacts on these different ecosystems. And it's not just the risks of these, the continual change of climate change. The other great concern is that we know there are risks of potentially catastrophic shocks to the climate system, very large or abrupt changes that could occur. And the sorts of things that we're concerned about as climate scientists are shown in these 4 images here. The potential for the very rapid dieback of the Amazon rainforest, the potential for the collapse of the vast ice sheets covering Greenland and West Antarctica, and the ensuing global sea level rise, which could be of many meters. Or the release of vast quantities of frozen methane as the Arctic starts to melt. And methane is a much more powerful greenhouse gas than carbon dioxide. We know that in the past, abrupt and rapid climate change has occurred. And the concern is that as the world warms up, the risk of these sort of catastrophic events occurring increases. Now, what I wanted to do was to pause for a moment now, and I've given you quite a significant overview of our current understanding of the risks posed by climate change. And I thought, well, let's pause for a minute and look at some opinion polling to understand how people are responding to the climate emergency. And so I've got a couple of questions here that I thought I would like to get your views on as well. And these are questions that have been asked in recent opinion polls. So the first question is, and you should be able to see on the screen where you can vote in real time as to your opinions. The first question I want to ask is, generally speaking, how concerned are you, if at all, about climate change? So if you want to vote now, then while we're voting, I will tell you, this question was asked earlier this year. It's been asked actually repeatedly over the last few decades, but the most recent opinion polling that I found asking this question came from YouGov in January of this year. And if I give you the results of what were the national opinion polling on this was, for the UK, around 74% of UK adults said they were concerned, so that's either concerned or very concerned about climate change, and 22% said that they were not concerned. And those sort of numbers have been broadly consistent over the last couple of decades in terms of climate change. Sometimes the population's been a little bit more concerned, sometimes a bit less concerned, but around about those sort of numbers. So I think we should be able to see what you all who have been watching have come up. There we go. So well, there you go, 72% very concerned, 25% fairly concerned. I think perhaps because you were watching a lecture about climate change, or maybe because I've shown you some of the real risks and impacts of climate change, higher than the national population. The second question I wanted to ask was about the current situation in which we find ourselves. And again, this is a question that was asked recently by YouGov in the UK. And that's this: regarding the overall impact on humanity, are you more concerned about the impact of coronavirus or climate change? So again, you can vote now, and we will analyse your answers in the moment. Of course, this isn't an either or. We've got to respond to both the emergency caused by the global pandemic and to climate change. But I think it's interesting to see how different people respond to this. So if I give you the results of the national opinion polling, 32% said they were more concerned about coronavirus and its impact on humanity, 45% about climate change. And there were differences between different groups of people. So in general, perhaps maybe as you might expect, younger people were typically more concerned about climate change, and older people typically more concerned about coronavirus. So let's see what you all said. Can we get that? There we go. 78% concerned about climate change, 18% more concerned about coronavirus. And what I'm going to come on in some of the later bits of this presentation is to talk about how, as we're responding to coronavirus, we can also look at how we respond to climate change. So let's look at both of those two things together. What's shown in this slide, first of all, over the last couple of decades, since 1990, are the global levels of carbon dioxide emissions coming from fossil fuel use. And the last year in which we have data, in fact, it was projected data, was from 2019. This comes from the Global Carbon Project. Those numbers have very recently been confirmed, and the confirmed numbers are ever so slightly lower than are shown in this graph. But you can see there's been a steady increase in carbon dioxide emissions over those last few decades. Now, obviously, we're living in very, very different times around the world right now, with lockdowns happening in many, many countries, including here in the UK. And it is thought that as a consequence of that, we may see this year the largest ever fall in carbon dioxide emissions. But there's a really important point, which I'm going to come on and show you in the next slide. The current estimates are that the sort of level of decrease that we might see this year as a consequence of those lockdowns that have occurred around the world and the really dramatic changes to global society are that we might see something like a 6% drop in emissions. Now, that number might be revised up if the lockdowns continue for longer than was expected in this sort of analysis, but nevertheless, it takes a lot to turn around the tanker that is the global machine that is creating these carbon dioxide and other greenhouse gas emissions. This graph here shows the data that I've already just shown you. The white dots are those global emissions of carbon dioxide. There's in the red dot shown what a projected 2020 number might be when we've seen that drop of some 6% or so compared to last year. But what's critically important is that envelope of blue curves that you see on there. That envelope of blue curves are the pathways of future carbon dioxide emissions that the IPCC, the Intergovernmental Panel on Climate Change, suggested in their report of almost 2 years ago, 18 months ago, would be broadly consistent with a reasonable chance of keeping global temperature rise below 1.5 degrees of warming. And just to recap again, we're currently at around about 1.1 degrees of warming compared to pre-industrial times. The Paris Agreement of 2015 said that countries who were signatories to that were committed to keep temperatures well below 2 degrees of warming, with an ambition to keep them below 1.5 degrees of warming. And you will recall that I've already shown you, as the warming increases, the risks to both humans and to the natural world substantially increases. So keeping temperatures below 1.5 degrees, or as close as possible as we could to that, is critically important. And what you will see from this is that even the dramatic changes that we've seen in the global society over the last few weeks only puts us broadly on track for the sorts of decreases that are going to be required year on year on year if we are to keep temperature rise to these sorts of limits. The transformational change that is required is really very substantial. And this is where I think that is possibly an opportunity for good to come out of what is a very dismal global circumstance we find ourselves in with the global pandemic. This lecture itself is happening virtually, and well, we'll see whether you think that this has been a good way to communicate to the world about this subject. But we're all finding that we're working much more virtually. If we can manage to encourage and incentivize virtual working behaviours and some of the other changes that we have been making over the last few weeks, then perhaps we can find ways of actually improving our lifestyles in many ways, but at the same time responding to climate change as we move out into the world beyond this current global pandemic crisis. Now, of course, not only have we seen the very dramatic impacts of coronavirus over the last few weeks, if we look back over the last year and a bit, we've also seen a really dramatic change in global society with respect to climate change. Greta Thunberg and the rise of the Fridays for Futures movement, school strikes, and around the world, really a dramatic change, I think, in the way in which society has started to say we really do need to respond to the climate emergency. And I think that is a real sense that's not going away, even within the period where we're acutely focused on the response to coronavirus. On the right-hand side there, I just show you two examples of the very dramatic changes that we're currently living within. As a result of the lockdowns that have occurred around the world, we've seen dramatically improved air quality in many cities around the world, including in London, reductions in the polluting chemical species in the atmosphere, including the particulate matter that causes so much ill health and indeed mortality, deaths around the world as a consequence of that poor air quality. That reduction in the vehicle use, among other things, has seen significant increases in air quality in many different cities. And the bottom image that I show here is the very dramatic difference that we've seen in air transport. This shows last Thursday, European airspace, air traffic levels down 87% compared to the previous year. It's going to be interesting to see whether or not, the changes that we've seen are going to lead, over the last few weeks that we've been forced into, are going to lead to longer changes in behaviour. And that's where I think there's real opportunities for bringing in technology. And again, this includes technologies coming from AI in terms of how we help to shape the global recovery from COVID. The global economic system has, as you'll all be aware, taken a huge hit as a consequence of the lockdowns that have been occurring around the world. So as we start to restart our global economy, can we do so? Can we reset the global economy and restart it in a way that helps to shape a cleaner future? And how can we bring in technology and technological developments to help with that? And so I've got just 6 examples over the next couple of slides of areas where I think there's real opportunity for making progress. And that's going to require a policy response combined with bringing in research and development and innovations. And the first area is in terms of clean energy investment. We've already seen a dramatic rise in recent years of renewable energy technologies, but they still represent a very small percentage globally of our energy generation. So how can we bring in new technologies in terms of new battery technologies, for example, or an example that's shown here is of work that's being undertaken in the chemistry department in Cambridge, developing artificial leaves to create synthetic fuels. How can we bring in research and development to help drive forward the energy change to a clean energy infrastructure? And that's going to require not just changes on the in terms of the supply of energy, but also in terms of the demand for energy. And that's where potentially AI can come in terms of helping people to use energy more efficiently by introducing smart technology systems. The next example I have is looking at clean industry. So there are many parts of industry, from the production of steel and cement to an example I've got here is the aviation sector that are very intensive in terms of their production of greenhouse gases. So how can we again bring in research and development to help support a transition to zero carbon industry? An example here is the development of electric planes, for example. And again, how can we bring in AI technologies to help rapidly speed up the development time of something like an electric plane? The third example I have here is of climate-proof infrastructure. So I already mentioned cement and steel production, which are critical to the development of infrastructure, are heavily intensive in terms of their carbon usage. Can we look to develop new natural construction materials, for example? Can we use AI to search for what those construction materials with the best properties might be and help in their development cycle associated with that? Then the next set of examples I have, clean living infrastructure. We've seen that we've all been undertaking very dramatically different behaviours, including this sort of virtual working over the last few weeks. But to support those going forward, to reduce the amount of time and carbon emissions that are associated with us travelling to work every day, we need to improve our for example, the access to broadband services around the country to enable people to more easily work at home. And the example that I've got here as well of new lifestyles is of what I've spotted in recent weeks around Cambridge is the postmen have started to use electric bikes to deliver letters and parcels in some parts of Cambridge. I think this is a trial that's happening in different parts of the country. But again, if we are to more generally use bicycles or electric bicycles, we need to make sure that the infrastructure associated with that has been improved. The fifth example I have here is around nature-based solutions. Having a much better understanding of how we can use nature to help reduce the impact of climate change is critically important. There's much talk about planting more trees, and that is important, although the right trees need to be planted in the right places. But there are many other aspects of nature which can be brought to bear to help respond to climate change. Soils, for example, store a huge amount of carbon within them. And so if we could manage to increase the carbon storage of soils whilst also improving other aspects associated with those soils, the biodiversity associated with them, their properties in terms of flood prevention, for example, then that might be a really important contribution. Now, you might ask, where can we bring AI into these sorts of nature-based solutions? Well, one area in which we're starting to more and more use AI is in terms of helping to analyze environmental data from around the world. We have vast amounts of data now coming from remote sensing, from satellites in space, sending us down measurements of all sorts of aspects of the natural world. And we can use AI and machine learning to help interpret that data and support things such as the development of these nature-based solutions. And then the sixth example that I have here is of education and training. As we move to a recovery from the current global pandemic, we're going to need to be focusing on ensuring that we are providing people with the skills and training for the jobs of the future. And we all know that AI and the digital revolution are going to be central to that. So ensuring that we are skilling people up with the right skills to move forward in the future, to be able to deploy the tools and techniques of AI and machine learning, but at the same time to respond to global challenges that we face, whether that is through future pandemics or it is through responding to climate change. That's going to be critically important. So I will leave it there and summarize. I hope that I provided you over the last 50 minutes or so a bit of an overview of the current state of our understanding of the scale of the climate emergency. The opportunities, though, as well, as to how we could respond to that in a positive way and help to shape a future that we can all be proud of leaving as a legacy to future generations, and how actually technologies associated with AI and machine learning are going to be absolutely central to that. So thank you very much for listening, and I hope you have a very enjoyable Earth Day, but use this 50th anniversary of Earth Day to have a thought as to how you might all want to contribute to help shaping the Earth into the future. Thank you very much.
Thank you, Emily. That's a fantastic talk, and we're going to jump straight into some questions now from the audience. We've had many, and I've been filtering them, looking through them all. So the first question, how has the CO2 emission picture changed over the past couple of months due to the lockdown across the globe?
Yes, so I don't have the exact numbers for that, because as I indicated, actually it takes a while to do the proper assessment of that. So we've only just got confirmation of what the global carbon dioxide emissions numbers were from 2019. So there's always a bit of a lag, so it's a bit difficult to give a precise answer to that, but all the indications are, as I said, that they are going to be reduced in terms of the emissions. What we do have continual, daily measurements of are the concentrations of carbon dioxide in the atmosphere, and the concentrations of carbon dioxide in the atmosphere are at their highest level ever. So the daily rates are now up above, at some stages even above 415 parts per million in the atmosphere.
Next question. How can we translate concern and awareness into action? So, for example, whilst we have been recycling across the country, most businesses and individuals consume and waste too much. Assuming the rest is recycled, so it's environmentally fine, recycling is inefficient and takes a massive amount of energy to collect and reuse. So, yeah, how do we translate concern and awareness into action?
Yeah, well, I mean, that's a central critical question, isn't it? How to translate that into action, how to encourage people to change behaviors, whether that's individuals or companies. Some of it, I think, is around helping people to understand what things can have the most impact. And that's where data really is critical and comes into helping people to make those decisions. So, should we be changing our diets to eat slightly less meat? Well, the answer is probably yes. Should we be changing the way that we travel so that we fly less? Again, the answer is probably yes. I think what's critical, though, is not only to understand what makes the difference, but actually where the other positive impacts of those changes might come in. So reducing the meat consumption in your diet has a positive health impact as well. And as we've all been seeing, reducing the amount of flying that you do, well, actually that can have benefits as well, or the amount of commuting that we do each day. It can have positive benefits to people's lifestyles. So understanding that these are not changes that necessarily are big, have anything other than positive impacts on your lives and lifestyles, and positive impacts for businesses as well, I think is part of the solution to that.
Excellent. How do you feel about the trade-off between explainability of the results versus the scale and ease of analysis that machine learning techniques such as deep learning offer?
Yes, so one of the things that's critically important if we're to apply machine learning or AI techniques in the climate area is to be able to understand and explain and interrogate the reasons for the results that are coming out. Now, if we're going to base decisions that are possibly either have severe financial implications, or they're decisions at which the future of humanity is at stake, we want to make sure that we understand why we're making those decisions. So the interpretability of whatever tools and techniques we are applying, that we're not just applying black box techniques, but we understand the reasons for generating particular conclusions is critically important. But that also lends itself to really interesting questions from the research side, because that is something that's of strong interest to many people in the machine learning and AI community, is to understand how to generate techniques that are interpretable.
Excellent. What are your thoughts on data collection and analysis of the gendered impacts of climate change? How can AI be best used as a tool to improve this area of data collection?
Of the gendered impacts of climate. Well, that's interesting. I mean, so I'm not sure exactly what the questioner is interested in there, but it's certainly the case that, I mean, the way in which gender and climate change intersect is very interesting. It's certainly the case that around the world, many of the communities or people within communities who are most impacted by climate change are often women. So there are often intersections between the impacts of climate change and who those are impacting most, and I guess understanding one of the things where I alluded to, where I think that AI can be most helpful, is in terms of integrating different data sets, so we have a better understanding at a local level of the impacts of climate change. And that's not just in terms of the physical impacts, but it's of the impacts on society as a whole. And so if we can start to draw in data at a local level of the way in which climate change is impacting particular societies, then that might be one example of where we can use data to help to better identify and resolve how climate change is affecting particular communities.
Do you think it's game over for fossil fuels, especially oil? Now it's cheaper to leave them in the ground than to extract and store them. Will cheap oil slow down? Will the glut of cheap oil slow down and dash to renewables and improvement in fuel efficiency?
Yeah, so well, as people will no doubt have seen, there's been times in which the global oil price has gone negative in recent days as a consequence of the really dramatic change in demand, as a consequence of the lockdowns, but also actually other geopolitical reasons that have been going on in the background as well. Is it game over for the fossil fuel industry? I mean, it's difficult. How the sort of numbers or the graph that I showed you of the really dramatic reversal in the level of carbon dioxide emissions that are required to have a reasonable chance of keeping temperatures below 1.5 degrees, I think pretty much gives you the answer as to where the fossil fuel industry needs to be heading very rapidly. It's just incompatible with keeping temperatures below 1.5 degrees to continue to use fossil fuels to generate our energy. And the good news is that there are increasing alternatives in terms of the technologies available. We've seen a dramatic increase in the solar energy production over recent decades, increase in wind. Many of these technologies, even before the recent crash in oil prices, were cost comparable now with fossil fuel generated technologies. So I really do feel that the future is undoubtedly in the direction of clean energy, zero carbon energy.
Thank you. Data science has been used for many decades to predict climate change. We know and agree that it is happening and poses high risk to our existence. What I am not clear on here is the mention of risks of climate change using AI in your talk. So what specific AI and specific risks are you do you refer to in your lecture? What are you working on, I guess?
Yes, well, Scott, this is what we've been doing together. So what we've been doing in particular is trying to combine together data that comes from future projections of climate change. And those future projections of climate change are typically made using global climate models that are based on our understanding of the physics of the climate system. And because we produce them numerically using computers, we do so by producing those projections on a grid. That's how we solve the physical equations. And that means that because we're producing them on a grid, the grid spacing in a climate model is often quite large, maybe 100 kilometers or so even. And if we want to understand what's happening at a particular city, for example, the risks of extreme weather at a particular city, then we have to essentially interpolate the results that we get from those climate projections down to that particular location. And where we are using machine learning techniques, first of all, is to do that interpolation, and we're doing it on the basis of integrating historical data that we have of how weather patterns have changed in the past to be able to better do that interpolation. And then the second thing that we want to do, if we want to understand risks, is to understand how that climate change or how those weather conditions impact different parts of society. So, for example, we might want to understand what the impact of heat waves are on people's health, and therefore what the future risks of future heat waves might be to global public health. And in order to do that mapping, we can similarly use data of past heat waves to and the impact on health of that to understand how to do that mapping. So it's different stages of the process that we're bringing in machine learning techniques in order to be able to essentially integrate different data sets to gain a better understanding.
Thank you, Emily. How does livestock impact CO2 emissions?
Yeah, well, so it's not just livestock, but different agricultural practices generally can have an impact on not just CO2 emissions, but greenhouse gas emissions more generally. So cows, for example, produce methane, and so if you have, and actually it can change slightly according to the cow's diet and so forth, but that causes an increase in methane, which is, I described, a very powerful greenhouse gas. In terms of other aspects of agriculture, fertilizer use can similarly generate greenhouse gas emissions. So there are different aspects of the agricultural sector that produce greenhouse gas emissions. And again, it's an example where slight changes in agricultural practices can have a really significant reduction in those greenhouse gas emissions, and another area in which AI is coming in, because there's increasing use of AI technologies in terms of helping to inform farming practices to reduce the greenhouse gas emissions.
So I'm aware it's 2 o'clock, but if it's okay with you, Emily, we might stick around for a little bit longer and ask a few more. Is that okay?
Absolutely, please do.
That's it, let's squeeze a couple more in. Right, so thank you for your engaging talk. As someone who has just become an aunt, I was wondering, what skills do you think will be essential for the future workforce?
So I think there's clearly we're going to be moving into very different times. So what skills are going to be essential for a future workforce? If we are really going to be able to transform society in the ways that are consistent with keeping climate change at bearable levels, then that really is a change across all of society. But that means many new jobs in many new areas. Clearly, we're ever moving into a more digital world, and so jobs with the skills in order to be able to help develop and run the technologies associated with that are going to be critical. As we've already been describing, the energy sector is going to be transformed, and again, significant opportunities for jobs associated with that, associated with changing the way in which we provide energy in our homes, for example. Most of us, our heating systems are currently provided by gas boilers, but in the future we're going to be needing to look at replacing all our gas boilers with heat pumps. That's going to be generating a significant number of jobs into the future. But the other area which I think is really exciting is the area that I described.
Oh, Emily, I think we've just lost you there. Emily, I think your voice is, I cannot hear you. Can you unshare your screen, Emily, see if that helps? Okay, it looks like we've just lost Emily. So what we will do, so we have we have a lot of activity on Twitter and the Q&A open here. So what we would do is let's continue this conversation on Twitter. If you have any questions, please use our hashtag use the Turing Lecture hashtag, the Earth Day hashtag. Put your questions on Twitter and we can get back to you there. So I'm afraid we're going to have to leave it there now. Thank you so much for joining us this afternoon. It's been fantastic. Emily's.
There we go.
We
said we might have technological glitches, didn't we?
We did.
Halfway through my internet went down.
It's good to have you back. I think we were just about to. We were going to have a couple more questions. So I've suggested to people that they ask questions on Twitter and that we can see them on there. So we cannot get to all the questions. So maybe we can continue this afterwards. But as we've got you back, I did want to ask you this one. So what should national governments focus on within the green agenda as part of the stimulus package for post-COVID-19 economic recovery?
Yeah, so, well, I think I tried to outline a few of the key areas towards the end of my talk there. I think, I mean, the first thing that is absolutely critical is that we are going to require a global response to COVID. But we also require a global response to climate change, and so bringing those two things together, I think, is going to be absolutely essential. We were to be hosting in November of this year the next big climate conference, COP26. That's now been delayed because of the current climate crisis. But if we could potentially use that, use our leadership within the UK to really try to ensure that the global responses to COVID are responses that are consistent with delivering net zero by 2050 or sooner globally, then I think we've got a real opportunity for taking leadership there. So it's about how can we collectively, as a global community, help to deliver net zero, and that involves all sectors of society as part of it. So looking at energy, looking at infrastructure, looking at jobs, as we've been talking about, and how we can support jobs of the future, looking at nature-based solutions. There's a long list that we could all be focused on as a global community.
Thank you, Emily. That's and I think on that note we will leave it there. Thank you so much, everyone, for joining us this afternoon. It's been fantastic to be able to engage with so many of you. If you would like to learn more about what we're doing at the Turing to combat climate change, please head to our website, turing.ac.uk/climate, and I think you'll see those slides now on your screen with some links. So please click on those or go to those sites. We'll be hosting our next virtual Turing Lecture in May with Stuart Russell. Keep an eye on our website for updates or join our mailing list. To be the first to hear about those things. You can find the link on the Contact Us link on our menu on our website, or click the link, follow the link shown on your screen now. And finally, on behalf of everyone at the Turing Institute, I would like to say a big thank you to Dr. Emily Shuckburgh again for joining us today. Thank you very much, and we'll see you soon.
Thank you, and stay safe, everyone.
Thank you.